what's the broader context too? Now, AI tools and even machine data doesn't exist in a vacuum. There's been a series of technological changes over the past 10 years or so, many of them predating the latest wave of AI tools that are important to understand because they change the context for what's possible in terms of data collection, data analysis, and the scale and ease with which you can do it. And I'll start with the first one, which is the oldest one. So if you go back maybe year 2000, 2010, uh, storage, like data storage for large amounts of data was somewhat expensive. Maybe it was on premise, a bunch of like hard drives, a bunch of servers. And so there was a lot of questions around, don't use too much of it. It could be too expensive. That sort of started changing around the mid 2010s, 2015s for a couple of reasons. Not because of factories, but because, some of these web companies like Facebook or Google, they had way, way more data. And it became very important for them to find a way to drive down the cost of storage. And then that led to these sort of side benefits where storage became super cheap. So storing large amounts of data was no longer expensive. We'll do an example like how much would it actually cost to store all the data in your factory, the part you are collecting, the part you're not collecting for a year, like how much will it actually cost? And I think it's $28 if you use modern storage technologies. So it's not expensive anymore. But the question is it valuable? So then, even though it wasn't expensive to store the data, as anyone who has tried to collect data in an electronics factory probably painfully realizes, it's still a huge problem to actually figure out how to integrate these systems together and even understand the data coming from the equipment. There were a lot of proprietary, still are, a lot of proprietary protocols, things only shared under NBA, a lot of things where you only get data to upgrade the machine. There's all of these sort of practical barriers, and they have not been fully solved. That's not the situation we're in today, but it has gotten better. And so I would say this is the next major thing that changed. And it started changing, around the late 20 teens, maybe into 2020. And in the electronics industry itself, standards like IPC-CFX, the Connected Factory Exchange, is an open protocol and language and schema for how electronics equipment can share data about what it's doing. Things like when you finish doing placement on a pick and place machine, what should you send about what you did? How should you structure it? How should you include barcodes or serial numbers? Even what format to use and how to send it. So that's something that made it much easier to collect data from equipment if they were CFX compliant. Obviously, not all equipment is, and CFX standard itself is quite large. So levels of compliance is always a challenge. So I myself am one of the co-chairs of that standard, along with Tom Markscheffel, formerly of ASMPT. And so anyone has questions about IPC-CFX, I'm welcome to talk to me in that capacity as like the standard co-chair. So another thing that happened, because as we'll see when we look at real world factory data architecture, not all equipment in the shop floor in your factories is capable of sending these sort of, call them holistic events, doesn't know exactly what it's doing. It's maybe a lower level piece of equipment. Maybe it's just a programmable logic controller controlling, just one little robot arm, or it's a bespoke piece of equipment. And these systems, it used to be that you had this giant driver library of like, how do I talk to my Siemens S7 or my like Omron PLC or my other Fennec controller? And that's still to some extent, like you have those libraries, but there's been a lot more standardization around OPC UA as a common way of sending all this information, making it at least possible to read and connect. And then also the companion standard of OPC UA that also says, hey, if you are this kind of equipment, maybe try to send this data in this way with these names and these tags. So these organizational concepts, and then what came out of this was the concept of unified namespaces, which is itself a not per se a standard, but a concept for how you organize data. Their goal was to decrease the amount of effort it required to structure and understand and collect large amounts of contextualized factory data. So you had, okay, now I can store it. Now it's easier to collect it, but you still have this fundamental challenge of the only, apart from some small automation use cases, really you're collecting it for people, right? Like you're collecting it to put ultimately, usually in a dashboard somewhere that you really hope someone's going to look at and then use to inform some action. And this was valuable, right? Because the data needed to be collected. You needed to do those investigations, say like a quality root cause investigation or a kappa, or maybe some sort of investigation on why you have too much attrition on your pick and place, these things that need to be done in the factory. But there was always a limitation, the amount of expert capacity you had to really look at this data and turn it into actions. And so that's what's starting to change now. And again, it has not fully changed. There's a set of things that are possible and a set of things that are not possible still. But for the first time, we now have tools that are directly addressing the analysis to action portion of how you might get value from data you collect in your factory. And that's super exciting as a practitioner of this for a long time, because this was always one of the primary bottlenecks. It didn't really matter if you had a perfectly structured dashboard with the exact answer there. Nobody looked at it, or no one has got time to look at it, or doesn't have the expertise to look at it. It doesn't really create any value, or doesn't really solve any problems. So the entire exercise would kind of moot. So this is sort of like what we'll talk about here. At the end of the day, the only reason to collect data, apart from, it's mandated for compliance purposes, is because you hope it's going to lead to some insight, and you hope that insight will lead to some action. So let's investigate this sort of value chain from data to insights to actions, and start with the data side. So the first piece, how do you collect it? Can you physically get it in one place? Is it too expensive? We'll talk about that question. Then insights. Okay, I've got my data. It's in a database somewhere. I did my job. How do you make sense of it? What does the time tell you? What is the insight? And then also, how do you communicate it? Is it a dashboard? Is it a report? Is it an alert, an email to somebody? So all these sorts of questions. And then, great, you've got some insight. Hey, my pick and place has a higher attrition than I think is normal. I wanted at maybe 0.1% and at 0.15. Okay, what should you do? Do I stop the machine right now? Do I adjust something? What might I adjust? There's a lot of different ways I could solve that problem, and it's not necessarily clear which one I should do. So this fundamental series of steps hasn't changed, but there's been two distinct areas I would highlight that the impact of this most recent wave of AI tools has hit. So one is in the how you collect it, and we'll see some examples of that in the second half of the course. Certain times where unstructured data that was hard to collect before has become easier to collect. So that's some pieces. But the area where the most exciting impacts I've seen have been is in this last section here. The what should you do and how should you do it? Being able to take what was maybe just a descriptive dashboard or description of a problem and then turn it into more prescriptive guidance, or pull, say, maybe a large SOP document, which in theory has somewhere in this giant Word file, everything you should do to fix maybe attrition on your pick and place, but it's not clear which part is relevant for the problem I have right now. What if you had a tool which could take all the data, what's actually going wrong? Oh, I see this pattern, that pattern, that pattern. Therefore, here's the sort of customized guidance to you, which pulls from the full SOP that's been proved, but pulls only the part relevant for the problem at hand based on what it's able to see from the collected data. So you go from just, giant training documents to maybe more focused guidance tailored to the problem at hand. So that's sort of all of the pieces here. And that's like sort of the context and how collecting data can ultimately turn into value. But there's sort of one, I guess, bigger piece of framing that I want to put on the table, because it sort of informs the link between why talk about machine data in the context of AI. And the link that I want to talk about is an analogy with a robot arm. You think about like direct production automation in the factory, maybe since the 1960s, 1970s. A lot of it was around, mechanizing assembly tasks with robot arms to do repetitive labor in an automated way. Whereas previously you had to have, a person standing there moving every chip or moving every, or putting in every screw. The way I would talk about AI now, and the way I think about its impact in the factory, is sort of like a robot arm for repetitive decision making. So it's not necessarily good for high value one-off decisions, but the kinds of things where it's like death by 1,000 cuts, where I've got 10,000 feeders in my factory on all my different pick and places, or maybe 1,000. And I need to monitor every single one and figure out when it needs to be maintained. Or I've got a bunch of nozzles, or I've got so many pins on all my ICT fixtures. The kinds of things where you could imagine a structured thought process that you wish someone had time to go through individually on every single one of those. monitor every feeder and think of its holistic lifespan. Look at its history. Like think of it as an individual feeder with a complete life cycle. But nobody's got the time. But that's sort of the kind of thing that these AI models are due for, which is it doesn't have to be a mechanistic flowchart. They're slightly more capable than that, but they can go through a thought process and they can do it in parallel on, say, each of 1,000 things or each of 100 things. And this sort of like automation of repetitive knowledge tasks is something that previously was very challenging to do. I would say if you go back maybe 20 or 30 years, you had the concept of expert systems, and that was a similar idea, but based around more simple rules. It was hoped that maybe I can just codify a really complex flowchart of all of the possible decisions that someone might have to make, and I'll just walk through that flowchart. You say yes or no, and then I'll guide you to the right answer. And there's some problems that was sufficient for, but a lot of problems you just couldn't build that flowchart. It was too complicated. It was too messy. It didn't really match with the reality of some of these more complicated real life decisions that people have to make. And so that system ultimately got limited. These AI tools, I see them now as in that similar vein of expert system, but with more flexibility. And so now there's a wider set of problems that they become applicable to, given them the advanced capabilities. So that's sort of like the piece here, which is there's opportunities now to have AI help with problem solving and management of the factory, in analogy to previous ways of automation focusing purely on the direct automation of assembly tasks. But there's of course a challenge with this, and that's why I link this to the concept of machine data and data collection. Because unlike a person, right, you walk into the factory, you see so much, right? Like with your eyes, all your senses, you see what's going on, you see the andon lights, you see maybe what's going on in screens, you see like data collected, you see, maybe overhead displays on each machine. You see so many things that your brain can interpret and react to in order to understand like what might be going on. And it's tempting to believe that the AI would work the same. It would be like just as good as a person and more. But it's actually the opposite, right? Whereas you see everything that is going on in the factory, the AI is really blind, right? Like everything that has not been digitized and put into a single place and then fed into an AI tool, it has no understanding of it, has no visibility to it. So imagine if you walk to the factory with your eyes closed, or if you're only allowed to see the andon lights, but you can look at nothing else. The amount of problems that you could solve would be fairly limited. And this is also the case with AI. It doesn't matter how good the models get. They could be perfect, but they fundamentally are non-corporeal, right? They don't have senses feeding into them. The senses is the digitization system of the factory. It's what data has been collected and put together in one place and physically given to a tool, a software tool at the end of the day to help with a decision. So this is the link between the ongoing trend of digitizing factories, of Industry 4.0, of collecting data and putting it in one place and structuring it. Is without that, there's really nothing for a software tool like an AI to react to or to interpret. So it actually becomes even more important to do the required work to put together these sort of complex and accurate data twins of what the factory is actually doing, how it's working, because those are the things that you could apply these increasingly capable models to support decision-making, especially some of the repetitive ones that are so important for actually determining operational KPIs and improvements in the factory. And so that's sort of like the link here, which is, if you have the process of putting data together, contextualizing it, harvesting it from all the various places it's generated in the factory and putting it in one place, that sort of ultimately builds the world that's available to use these increasingly powerful tools. And that's why this course is broken up into those two sections.